Hello everyone, thank you for joining today's session presented by LiveAction. Today's webinar is on DMVPN QoS for Intelligent WAN. I am Clark Zeller and I'm a sales engineer with LiveAction, and I will be the moderator for today. And the agenda that we're going to follow is we're going to begin with a brief introduction. We'll then have a DMVPN concept review, followed by QoS concept review. We're then going to have a very technical deep dive into both DMVPN as well as QoS technologies. And then throughout our deep dive, we're going to have several live demonstrations of the actual DMVPN network and see how to both configure as well as confirm and validate your QoS policies. Now, the reason for today's session is DMVPN is a core part of Cisco's Intelligent WAN or IWAN solution. LiveAction is a technical partner with Cisco, and we've worked very closely with Cisco to help develop a visual network management platform to support these emerging technologies. So let's begin with our DMVPN concept review. And before we do so, let me just step back 1 second and let you know that throughout our time today, if there's any questions, you can use the console of the WebEx to ask them. As well, throughout our presentation, we are going to be having some pop-up questions. Feel free to answer those questions, and the folks that answer the most questions will be put in a pool, and we'll hand out some t-shirts at the end. So stay tuned on that. So with that, let's start our DMVPN concept review. So when we think about our WAN environments, a typical WAN environment, at least traditionally, has had a data center like we see here to the top of this slide. And it's connected to a private WAN, and then we have several remote branch offices also connected to that private WAN, and we will purchase an amount of guaranteed bandwidth from a service provider over this private WAN. And in some cases, we may also purchase some level of QoS, where our service provider will recognize our critical data applications, our voice or video, and protect that data as it crosses their backbone and then egresses back toward our equipment. But due to the cost of private WANs, many folks have looked for an alternative, and one alternative, of course, is the internet. Many times you can buy very cheap bandwidth on the internet, and what folks have done is used VPN technologies to interconnect their branch offices over the internet back to their data center, and this has worked very well. But with the proliferation of voice and video, it's become a necessity to build any-to-any or full meshed VPN environments. And these environments have become very difficult to manage, if not impossible. As for a very small network like we see here, there are many tunnels that we would have to configure by hand. And this is a simple network, but think of a real network that would have maybe hundreds or potentially thousands of branch offices. That would be thousands of VPN tunnels that you would have to configure and try to manage and maintain, and it just becomes infeasible. So what the solution for that is DMVPN, or Dynamic Multipoint VPN. And what these do is these allow you to configure just one VPN, but dynamically in the background, with the magic of the next hop routing protocol, which is a core component of DMVPN, you'll have the ability to have that. So you'll only configure your VPNs between the branch office and the data center, but what will happen transparently in the background is you will get any-to-any VPN connectivity. So this is what has made DMVPN so popular. So that ends our concept of DMVPN review, and we're going to now dive into QoS. And let's talk about some QoS concepts very briefly. So when we start talking about QoS, all we're really looking to do is find a way to protect our voice, video, and critical data applications as they traverse our network environment. Since it's infeasible for most folks to be able to purchase enough bandwidth to allow all of our applications to run all the time, we need some level of prioritization to ensure our critical apps get where they need to go when they need to be there. We also need to understand that QoS is a suite of tools. It's not just one technology, and each of these tools will work in conjunction with the next to formulate a holistic QoS policy. We also need to understand that not all devices in our infrastructure are created equally. For instance, Cisco Enterprise Class routers typically have the full QoS tool belt at their disposal, where traditionally Cisco Enterprise Class switches have not. We also need to understand that our enterprise class routers will usually do QoS in software, where our switches will do it in hardware-based ASICs. This means there's no performance impact when we run the tools available at our switches at that LAN level. How about where do we need QoS in our network environments? Well, the short answer is we need QoS wherever congestion can occur. And this definitely can occur at our WAN edge, and that's definitely a place that we're going to want to look to have QoS. In many environments, we'll also want to have QoS at the LAN level. Now, if you're just getting started with QoS, I would definitely recommend only focusing on implementing QoS on your WAN edge, and then once those configurations are validated and known to be good, then turn your attention to the LAN level. How about the WAN itself? What do we do about QoS over the WAN? Well, if we use a traditional service like MPLS that was going to be QoS aware, our service provider will understand our critical data and allow us to protect our voice, video, and high priority applications as it traverses their backbone. But if we begin using the internet with DMVPN tunnels, what do we do then? Well, the good news is the traffic that we put into our tunnels can be protected via QoS. We can schedule how traffic is put onto our tunnels, but the underlying internet, of course, has no knowledge of QoS and has no concept of prioritizing our voice, video, or critical data. So that's one of the first key concepts that we need to focus in on in today's conversation, and that is we need to understand how to protect our tunnel traffic from the rest of our internet traffic. Another key conversation that we need to think about is even though we can protect the traffic in the tunnel, how do we do those configurations? How do we do that for one tunnel? How do we do that for hundreds or potentially thousands of tunnels? And those are the things that we're going to have to dig into and explore in our technical deep dive. And the two topics we're going to hit are just that. A, we're going to learn how to protect our priority data within our tunnels, and two, we're then going to learn how to protect our tunnels from the rest of our internet traffic that we send and receive. So let's dive into how are we going to protect our priority data in our tunnels. And if we think about a DMVPN network such as this, since it is any-to-any or fully meshed, if we were to eliminate the internet from the equation, because that's all we care about protecting our VPNs, is we could think of that as a full meshed high bandwidth WAN, similar in concept to maybe a Metro Ethernet service, where the service provider has no QoS. So if we think about that type of design methodology, it's actually pretty cut and dry what we need to configure in concept. Our remote branch offices are going to get a hierarchical QoS policy with a parent shaper policy and a child queuing policy, such as the one shown on this slide. And then the data center side of this type of configuration will have multi-class hierarchical QoS policies where we will define a class for each remote site. Each class's site configuration will have a shaper and then a child policy, and this will allow us to define bandwidth that would go to each unique remote site. If that unique set of bandwidth becomes congested or starts to overdrive the shaped rate, the queuing algorithm will then kick on and we will protect the traffic to the remote branch offices. In concept, you could think of this similar to the old days of frame relay and PVCs, where we have dedicated bandwidth going to each of the remote sites. So how do we actually configure these tunnels? Well, there's a couple different ways we can actually configure a tunnel on a Cisco device. One configuration methodology is with a multi-point tunnel, and this is the most common tunnel configuration. And a multi-point tunnel is what you will have on your DMVPN head-end at the data center, as well as usually you will also have this configuration at your remote branch offices. The downside of this is you cannot put your QoS policy directly on the tunnel interface. You just can't do it, so we're going to ignore that for now. Another type of tunnel configuration is a point-to-point tunnel, and in some instances, some customers will have a requirement to configure their remote branch offices as just point-to-point tunnels. You can configure a QoS policy on a point-to-point tunnel, but typically you don't. So at least in this conversation, we're not going to focus on that. But we are going to focus on what you should do most all of the time, and that is you will configure your QoS policy on the corresponding physical internet circuit of that your DMVPN will terminate on. So this brings us to a time of demo. Let's dive in and see what this looks like from a practical perspective. And what I'm going to do is I'm going to shift gears and I'm going to show you LiveAction. And LiveAction is an application-aware network performance management tool with QoS control. And what I mean by that is we can visually show you how your networks are performing, as well by utilizing the latest NetFlow technologies from Cisco, we can actually show you how your applications are performing. And then with our QoS controls, we can create QoS policies, modify and manage QoS policies, as well as visually validate how your QoS policies are performing. So that's what LiveAction is about. And what we're looking at on my screen is a network map. And this network map is comprised right now of 3 routers. They are interconnected via an internet circuit as well as a DMVPN network. And what we have here is a device labeled data center, remote site B, and remote site A. And we're going to dive into this configuration throughout our time today and uncover several different QoS configurations specifically for DMVPN. Now, what we want to do is let's take a look at what we can do from a flow perspective with LiveAction. So LiveAction is definitely a NetFlow collector, and if I was to click on my flow tab, I can see with these multicolored arrows painted across the network map, a visual representation of the traffic patterns or the NetFlow data that we're collecting from your environment. Now, right now, I'm looking at this by our display filter color. So we're looking at these by generic application types, and we can see that yellow is voice, blue is video, and so on. If I was to change my color mapping to that of DSCP value, I can now see that same traffic, but from a color coding of our quality of service priority markings. So now red is EF or voice, gold is AF41, video, and so on. So let me do this. I'm going to implement a filter that I've pre-canned, and what this will allow us to do is just focus in on the traffic going to our remote site A. As well, I'm going to implement a further filter, and I'm going to type in flow.dscp equals, say, AF41. And this is going to be our video traffic passing through the network environment, and there we can visually see how our video traffic is going, and we can see where in the network is that passing. And from here, what I'm going to do is I'm going to show you how using Cisco technologies, LiveAction can help you understand your application performance of, say, video traffic in this specific example. So what I'm going to do is I'm going to double-click on this device, and what I now see is the raw real-time NetFlow data that's being collected by LiveAction. And if I was to select, say, the MediaNet tab right here, I can see here are the performance statistics of my voice and video traffic passing through the device, and we're actually being warned by LiveAction that we have some high packet loss occurring in this specific device. So that's something we're going to definitely want to take a look at. Another thing that makes LiveAction so powerful is not only can we show you where there are performance problems with voice and video for one device, I can actually do this same concept for multiple devices in my environment. And what I'm going to do is I'm going to select a conversation, and I'm going to execute a MediaNet flow path analysis. And what this is going to do is allow us to visually track one conversation through our network. And if I was to look at the network map now that I've run that MediaNet flow path analysis, I can see the first hop of this video call, for instance, is good based off the green color, but the second hop is showing us performance problems in red. If I was to come back and look at our flow path analysis information again, I can see in the table tab of the flow path analysis the device's performance measurements, the input-output interfaces, the QoS policies that this specific conversation is passing through, as well as the voice, both jitter and packet loss measurements. Now, there's definitely a problem here And we need to understand what that problem is. And one thing I can see here visually by doing this flow path analysis is notice how there's no QoS policy on the egress or the output side of my data center device. That's definitely a problem. Well, I can use LiveAction to easily implement a QoS policy like that. And before I do implement that policy, what I'm going to do is I'm going to show you what the QoS policy looks like on my remote device. So what I'm going to do is I'm going to click refresh so we see our video traffic, and we'll then remove our DSCP filter so we see all the traffic going back to the network environment. I'm going to click on my QoS tab, right-click on my remote site A device, go to QoS, and manage QoS settings. And what we're going to see on this remote device is that there is a QoS policy applied to the WAN interface. I can tell you that the Fast Ethernet 8 interface is the WAN interface in this example. And then here's the name of that policy. If I click on my Policies tab, I can visually edit and understand how is this QoS policy configured on this device. Here is a view of this QoS policy, and I can see that it is a hierarchical QoS policy with a parent class. The parent class is shaping at 2 megabit in this instance, and the child policy is a queuing policy. And if I want to, I could then pick apart the queuing policy and see that we have VoIP and video listed with priority bandwidth, and then the rest of our critical data is also being reserved an amount of bandwidth. So that's the type of configuration that is on our remote site A. As well, what I can do is I can drill down, and I can understand by double-clicking on the internet circuit. In this case, I can see where our QoS policy is assigned to that internet circuit. I can also see the performance statistics of that internet circuit. So that's our remote site, and that all looks to be good. But as we looked from our MediaNet flow path analysis, we learned that our data center did not have a QoS policy on its WAN interface. And I'm going to double click on our data center device. I now see a list of the interfaces we're managing on this device. I do see that the data center device does have a QoS policy applied to its LAN interface, but not its WAN. So what I'm going to do is I'm going to right click on the WAN interface of the data center device, go to QoS, and then apply policy to interface. And what I'm going to do here is I'm going to select a multi-class hierarchical shaping policy, and I'm going to tick to apply it to the output direction, and that simply, I have now added a QoS policy to my data center device. Now, if I want to investigate this further, I can definitely do that. I'm going to right-click on my data center device, go to Manage QoS Settings, and then we'll be able to dive in and understand what does that hierarchical QoS policy look like. Here is that hierarchical QoS policy. Again, it's a multi-class hierarchical policy, and we can see several classes, and these class names equate to remote sites. We can say remote A, B, C, D, E, etc. If I was to click on remote site A, I can see where the classify section of remote site A's class is an access list, also called remote A ACL. The same applies to B, C, D, E. That's how we're defining our classes. Each remote site gets a class, and then each remote site also gets a shaper. So if you notice, remote site A has a shaper of 2 megabit. Let's click on the shaping tab. We can see the configuration of that. And then the rest of the remote sites that we've configured have a shaper of 1 megabit. So if we'll return to our remote site A, we can then look at the child queuing policy. And it happens to be an identical queuing policy we're using, but each time the queuing policy is applied to a child policy in a hierarchical configuration like this, each class will get its own instance and will be queued individually from all the rest. So you're truly carving out and guaranteeing an amount of bandwidth for each remote site in this instance, and then queuing when that guaranteed or shaped bandwidth becomes congested. So that's what the configuration looks like for this type of data center device in the DMVPN configuration. And again, we applied that QoS policy on the physical internet circuit in this instance. If I was to double-click on this interface, here I can see to the top of this screen, this specific interface is running NBAR, and I can see that we have RTP traffic or voice and video traffic. We also have a lot of FTP traffic that we are apparently downloading from our data center. We can see there's Citrix as well as other protocols. Here we can also see to the bottom of the screen a view of the CBQoS MIB. This is an actual view into the real-time performance of the QoS policy that is applied to this internet circuit in this example. And if I wanted to, I could focus in on just my remote site A's traffic. And when I do that, notice how, if I zoom in on this graph, it's coming in at right at 2 megabits. So this means that the shaper is active because I have such a smooth bandwidth graph line. I can also look at the performance statistics in the table and understand that it really is being capped off at 2 meg. But even though I'm pushing the full shaped limit, my queues are doing their job and I am fully protecting my voice, video, and critical data. So now that we've understood how we can use LiveAction to configure as well as validate QoS in your environment, let's go back to our practical example where, remember, we had seen packet loss when we had looked at MediaNet information on this remote site. Now that we've implemented that QoS policy here that should protect our voice, video, and other high priority data from maybe an FTP transfer like we saw, a lot of FTP data on this interface, right? Well, if I come back home, come back to my Flow tab, double-click on my remote site A, notice how now I no longer see any red packet loss in my MediaNet flow information. I'm no longer being alarmed about that condition. If I was to come back to home and go back and re-implement maybe a flow filter like flow.descp equals AF41 and just track my video over the network environment like that, go back to my table tab, and I'm going to again select maybe a video conversation, do a MediaNet flow path analysis. When we look at this MediaNet flow path analysis, we are seeing the first hop is still good. The second hop, we still see loss here. But when we run a MediaNet flow path analysis, we are doing it for a 5-minute time window. And since we just fixed this issue, we're going to have to wait for that to time out, and then we will see the lack of packet loss, because when we come back and look at the real-time information, the real-time flow information we have is showing us no packet loss after implementing the appropriate QoS policy at the data center. So let's do this. I'm going to now flip back to our slide presentation, and let's talk about another very important QoS concepts as it applies to DMVPN. And the first concept we're going to talk about is QoS Preclassified. You'll see this command referenced in several configuration guides, and let's talk about why you may or may not want to use this. So let's first talk about what a VPN configuration looks like without the QoS Preclassified command enabled. So let's say we have a packet, and the packet's been spit out from a NIC on our LAN, and it's destined to the internet, and it's going to be put into a VPN tunnel. Well, that packet's going to have an IP header. It's going to have a TOS byte as part of the IP header. That's where our DSCP value or our quality of service marking will go. We also have a data payload of that packet. As soon as that packet hits our DMVPN router, it will look just the same as it was spit out from the NIC or thereabouts. We'll also see that that packet, as soon as it hits the router and the router determines it needs to go into a VPN, it will become a GRE packet, and then it'll become an IPSec packet. And then that packet will go through an egress QoS policy. Now that egress QoS policy, when it sees this packet, he will see it as an IPSec packet. He will have no knowledge of the original payload except for the DSCP value or the quality of service marking on that packet. Notice how the blue quality of service TOS byte, how we have in the slide, stay blue all the way through, and then as the packet is egressed out into the internet, it would still look just the same. So that's our QoS configuration for a VPN tunnel without the Preclassified command. If we enable the Preclassified command, what happens is as the packet gets transformed from GRE to IPSec, a shadow copy of the original packet also gets created, and the egress QoS policy can reference the shadow copy of the original packet. So that means the egress QoS policy has the ability to look into the original header, so the source and destination IP address, as well as the original TCP and UDP port information, for example. So this will give you more options of how that egress QoS policy could potentially enact QoS on this data, or potentially say queue this traffic in this specific queue. Now, if we think about this for a moment, we can actually kind of determine in our environment, is it really worth doing QoS Preclassify, right? So notice here how without QoS Preclassify, our DSCP value stays consistent and uniform as it goes through its transformation from just a raw data packet to an IPSec packet, for instance. And if we wanted to, without Preclassify on, we could put an ingress QoS policy on the LAN side of a DMVPN router, and we could remark the DSCP value as we determined, and then that remarked value would also be seen as it goes through its transformation and becomes IPSec. And so when the egress QoS policy was to look at that IPSec packet, he could see that new marking and then enact QoS on egress as appropriate. So from my perspective, I'm not sure QoS Preclassify is really a requirement, especially when you think about how it's usually best to mark your data as close to the source as possible. So in theory, at the LAN level, you've already determined what DSCP values you want your traffic to be marked as well. When you get to the ingress of this router, you could also remark as applicable. So I'm not sure a Preclassify is really going to buy you a lot. There's another thing that I want to talk about with QoS Preclassify, and that's this. I'm going to quickly turn back to our demo environment, and I'm going to come to my QoS tab and then double-click on, say, the WAN interface of our data center device. And notice here how we're seeing our real-time QoS statistics. I'm going to right-click on the data center device and go to Manage QoS Settings. And what I'm going to do is I am going to enable QoS Preclassify on the tunnel interface, because again, that's where you enable QoS Preclassify. So I'm going to tick that box to enable it. I'm going to click Preview CLI. That's the change that's going to be made in this example. And I'm going to close that. That looks pretty good. I'm going to click Save to Device, and we've now turned on QoS Preclassify. And what we're going to see here in just a moment is the QoS statistics in our window stop populating the way we like to see. And from my own anecdotal experience, and I've done this for multiple types of hardware platforms, very old hardware platforms to the latest available, as well as I've done testing, and I've seen this in real customer networks from very old software all the way through to the most modern code that you could download today. I've seen just anomalies with using QoS Preclassify. And if you notice here in the background, we can see where our QoS statistics are no longer being populated. Now, with that said, as I untick the box and turn off QoS Preclassify, there are some environments where I'll see, even with QoS Preclassify, everything works appropriately. And what I mean by this is not only when you do show commands at the CLI level, as well as use management tools like LiveAction, everything works. And so I've just seen several anomalies. So in my personal view, I think by everything we've just looked at in our slides, we can adequately determine that we do not need QoS Preclassify and can ensure we always have the benefit of management tools without it. So that brings us to our next topic that we're going to want to discuss, and that is per tunnel QoS. And we do this at the DMVPN head-in device. And what this looks like is this, remember on our data center device with a traditional QoS configuration, we're going to have a multi-class hierarchical QoS policy where each remote site is going to have its own class and will shape and queue as appropriate within that remote site's class. Well, think about a real DMVPN network that may have hundreds of remote branch offices in this example. That's going to be an enormous QoS configuration that you're going to have to configure as well as manage over time. And it becomes very, very cumbersome at best to be able to manage that. Well, the good news is Cisco has created a fix for that, and it's called per tunnel QoS. And the way it works is on our branch offices, what we will do is we will assign a group membership, and this is an NHRP group membership. NHRP, again, is one of the underlying protocols that is a core foundational element of DMVPN. And so we're going to assign a NHRP group to the remote sites. And so what will happen is as they register, as their tunnels fire up and connect to the data center, not only will the data center have the tunnel information, it will also have a group flag, if you will, or tag that it can then reference, and then the data center is going to perform a mapping, and it's going to map the group ID with a specific QoS policy. And what ends up happening by this is A, here's the configuration or the NHRP group command you would put on a tunnel interface to the remote site. But B, on the actual data center device, here's what the configuration will look like. Instead of having to have hundreds or potentially thousands of lines of code, you can modularize your configuration so it just becomes a few commands you have to implement. Again, the NHRP map of our groups happens on the tunnel interface itself. So we're not going to have any QoS configuration on the physical interface anymore at the data center, but instead we're going to use this new NHRP map and grouping and corresponding service policy. So let me flip back to LiveAction, and we can show you where you'll get the same type of benefit as a traditional configuration that would be potentially hundreds of lines of code long, but you only have to configure a very basic policy. Oh, and actually before I leave this and head off to our demo and show you this, I do want to reference a couple show commands that you'll find very handy. One is show DMVPN detail, and what you'll see in this command is the actual details of the IP addresses that make up the tunnel endpoints to the remote site. You'll also see the group membership and then the corresponding service policy or QoS policy that is being used that maps to that group ID. So that's a handy command to know, show DMVPN detail. Another command that's very handy is show policy map multipoint. You may be familiar with a sister command, if you will, of show policy map interface that you may have used for traditional QoS validation. Well, show policy map multipoint, what it does is it shows you both the tunnel information and then the corresponding QoS policy that's applied to that specific tunnel. So I have definitely edited this show command and truncated it so it can all fit on one screen. But if you're familiar with this command, it will make a lot of sense, as this command obviously can get very large, and you'll want to use some of the shortcuts available on iOS to pick apart this command and see just the QoS details you want. But the details of how per tunnel QoS are all available at the iOS level. All right, so that brings us to our time of demo. And where we are is I'm going to look at my data center device, and remember how when we were on our data center device, we had our multi-class hierarchical policy applied to the WAN interface, which is the internet circuit in this case. If I double-clicked on that, we would actually see the QoS configuration stats of what's happening in that policy. Well, I'm going to right-click on my data center device, go to QoS, and then I'm going to go to Manage QoS Settings. And what we're going to do is first, we're going to remove that multi-class hierarchical policy from the WAN interface. And then notice how LiveAction has detected the NHRP group information for us on the tunnel interface. And what I can do is I can just right-click on the applicable group, say Apply Policy to Interface, and then I can assign the applicable QoS policy. So Group B will get a shaping value of 1 megabit, and Group A will get a shaping value of 2 megabit. Now, a key concept to this that I don't think I've mentioned yet, and it's very important, is when you are creating your QoS policies for group membership. Typically, you're going to do this by maybe bandwidth profile, where you'll have a group of remote sites that you could categorize as using a similar bandwidth footprint or QoS policy footprint. They could all become one group. Then you could have another group of devices that would maybe be another bandwidth footprint, and that would be another grouping. And by doing this, not every remote site has to have its own group, but you can group your sites and then alleviate the need for massive QoS configurations at this data center device. So now that I've made that change via LiveAction, I'm going to click Preview CLI. Here's the configuration that LiveAction is going to push out to this device, just like we saw in our slides. We're going to have our NHRP map of the group name and then the applicable service policy applied to it. I'm going to click Close and Save to Device. And once LiveAction's pushed that change, let's quickly review what these configurations actually look like. It's just a very basic hierarchical QoS policy each, where shaping 1 megabit really does have a shaping value of 1 meg. That was to highlight my class default and come to shaper. There's my 1 meg shaper with a nested QoS queuing policy. Same thing for shaping 2, nested queuing policy, just like we're used to seeing. Now, as I close this window, notice how there are no performance stats showing up on my WAN interface anymore, and this is correct because we removed the QoS policy from the WAN interface. If I go to the tunnel interface, notice how there's no QoS stats on the tunnel interface either. Now, the reason for this is Cisco has not yet added the CBQoS MIB to the per tunnel QoS configurations. So there's nothing for LiveAction to reach out and grab. There's no data there. There are show commands on the device, but nothing from this tool. But what's great about LiveAction is we give you a workaround. Check this out. I'm going to right-click on my tunnel interfaces bandwidth graph, or where the bandwidth graph would typically be, and I'm going to go to Show Flow. And what we're going to now do is look at the net flow data we're collecting on this interface. And so right now we're looking at the data center device, tunnel interface, outbound direction. And instead of looking at this specific view that shows us the applications going out this interface and what volume, I'm going to instead select a destination site traffic report, execute that report. I'm looking at the same data center device, same tunnel interface, same outbound direction, but notice how we are going to classify the bandwidth by site. If I was to right-click on remote site A, drill down and run a DSCP report, now we are seeing the DSCP values of the traffic being spit out our tunnel interface in the outbound direction specifically for remote site A. So this is the equivalent of the QoS stats that we were seeing before. So even without the CBQoS MIB being there for our per tunnel QoS, LiveAction has you covered, and you'll still be able to see exactly what's happening on these very complex QoS configurations. Alrighty, so I'm going to close this, and I'm going to go back to my home screen, go back to Flow, and let's now return back to our slides. And what I'm going to do off screen, you can't see this, but I am kicking off a FTP session. And the FTP session I'm kicking off is going to be from this server here and this PC. So I just downloaded a couple FTP files, or a couple files via FTP from this server. In just a few moments, we will start to see our flow data repopulate, and we'll start to see that FTP session. Looks like we already are starting to see that traffic. So while we let that percolate for a minute, I'm going to return back to our slides and talk about the next part of our conversation, and that is this. How do we protect our tunnels from our internet traffic? And this is the hard one, and this is one that I personally see a lot of folks get tripped up on, and it can be a very complex topic, but it actually can be simplified, and we're going to show you a couple quick examples of how we can do this and effectively protect our tunnels from our internet. And here we go. So if we think about our DMVPN networks, like we've seen before, remember how our internet has no understanding of the priority data in our VPNs. It doesn't even care that it's VPN. It just sees some IPSec traffic passing between our sites as well as all of our casual internet usage per se, right? Well, if we think about the traffic patterns of one of our devices, so we have the internet, then our DMVPN router, and then our LAN, the traffic going in the egress direction is typically a lot less than the traffic coming in the ingress direction. We're usually sending less bandwidth than we're receiving. For our egress traffic, whether your traffic patterns match this or not, remember how in the egress direction we always have the ability to control what is sent with the QoS configurations we've already just looked at. So we'll always be able to ensure our priority voice or video that may be going through a tunnel interface is protected, and we can ensure that that tunnel information is also protected against our casual internet traffic. But the ingress traffic is where our problem lies usually, and what we need to think about is how can we protect our ingress tunnel traffic from our casual ingress internet traffic. Well, one thing that is available in some circumstances is our service providers will actually apply QoS on our last mile. Few service providers do this now, and what's great about this is you can purchase from them the ability for them to guarantee your tunnel traffic over your regular casual surfing traffic. You can dictate, I want so much % of the link, for instance, as long as the tunnel uses up to that amount of bandwidth, the tunnel will be protected. And as well, a nice feature of this is if the tunnel's not using all the bandwidth you've purchased for that given time, your internet traffic or your casual internet traffic can still consume all of the link's bandwidth as appropriate. The downside to this is this type of configuration is not yet widely available, as well as there's a potential cost. And typically, the whole reason we're talking about DMVPNs is to save money. Another way we can protect this is by an ingress policing policy. So we would put an ingress QoS policy on our WAN edge device on the outside interface, and we would carve out a predetermined amount of bandwidth that we will dedicate for casual internet usage. As long as the internet traffic does not oversubscribe that policer rate, we will allow it through. But if we try to use more bandwidth than the policer allows, we would drop that extra traffic. This would allow our tunnel traffic to have a guarantee whereby we have limited our internet traffic. Now, the downside to this is it's not very flexible. What we have policed is a hard-coded limit. There's nothing that allows us to have our casual internet traffic adaptively be able to consume unused bandwidth if the tunnel doesn't need it. So it's always locked in, and we don't have much control over that. So definitely this works as well, but I would use this as a backup option. Now, a third way we can protect our inbound traffic is probably actually going to be the best way. And it's not very well known, but it's really a great method of protecting our ingress traffic. And what it is called remote ingress shaping. And what this is we are going to apply a egress QoS policy at the LAN. Now, what this QoS policy is going to do is it's going to control TCP conversations from the internet. Here's what that configuration looks like. It's very similar to the configurations we have already looked at, but you apply it in the egress direction on your LAN interface. Now, another key to this configuration is the shape command. We are always going to shape with a target rate of somewhere between 85 and 95% of the target. In my cases that we're going to look at today, I've shaped to 95%, and that has worked well. And again, what we are protecting against is TCP. So if you think about TCP conversations back from the Network 101 days, remember how TCP is a reliable application, and it is reliable in that it will send acknowledgments. So for so many packets that are sent by a sender, the receiver is going to acknowledge that traffic. And if there's a detection of packet loss, we're going to see retransmissions, and retransmissions are going to be indicators for the receive window to be lowered, in which case the sender will send less traffic. So by putting the shaper in place that we are then going to have a hierarchical queuing policy within it, we can thereby force TCP to selectively or start dropping traffic and then thereby protecting our critical data. Let me show you a practical example of what this looks like, as it's really a very powerful tool. One final thing before we go is this is only applicable to TCP. UDP is not protected by this configuration, but the good news is in most cases, internet traffic is TCP based, so this is still a very effective tool. So here we are back at LiveAction. And remember how we had kicked off our FTP session between my PC and our server. And if we were to click on, say, the LAN interface of this device and go to my QoS tab and look at the NBAR statistics on the LAN interface of the remote site A device. This is looking at the traffic as it's egressing this device head toward the LAN. We can see FTP is the top talker, and it's capping out at around 2 megs. That's just what we want to see. That looks right. If I come back home, go back to Flow, and double-click on my remote site A device, notice how, again, we are seeing problems with NBAR. Not NBAR, excuse me, we're seeing problems with MediaNet. This is our video traffic that is dropping traffic, and MediaNet is finding that application performance problem for us, and we are being highlighted about that application performance problem. Now, what's actually happening here is, remember how our tunnel is being able to receive at 2 meg from our data center, and we are also able to send 2 meg of internet traffic to this site. And the tunnel and the internet are competing for the same 2 meg of bandwidth, and so there's nothing that's allowing our voice and video to truly have a guarantee as it ingresses this device. And so what I'm going to do is I'm going to right-click. First, I'm going to go to the QoS tab, then I'm going to right-click on this device, go to QoS, and then go to Manage QoS Settings. And what we're going to see here is I have created a remote ingress shaping policy here. I'm going to click and I'm going to apply it to my LAN interface, which is gig 0. I'm going to apply it in the outbound direction, and I'm going to select my remote ingress shaping configuration. That looks okay. I'm going to click Preview CLI. That looks good. I'm going to save to device, and we've just applied our remote ingress shaping policy. But again, we've applied to the outbound of the LAN. And if I come and look at this policy, it's just a very typical hierarchical QoS policy. The only difference is our shaped rate, in my case, is 95% of the target, which is going to be 2 megs in this instance. And what is important about this, again, is we are going to have TCP reset itself or understand based off of retransmissions and windowing. It's going to figure out what is the peak rate it can safely send out, as well based off the queuing policy that we have applied to this remote ingress shaping policy. We are going to allow protection for both voice and video and our critical data applications. Now, what I'm going to do is I'm going to come back to Flow, and again, I'm going to double-click on my remote site A, and you notice there still are a couple of flows that are indicating packet loss, and this is A-OK because NetFlow is not a real-time protocol. It's always going to be delayed by about a minute to a minute and a half or so. It looks like we have good timing. It looks like our problem flows have timed out. That was very good timing. We're normally not that lucky, but here's what we have just seen. By implementing that remote ingress shaping command, we have adequately protected our voice and video traffic from our casual internet data. If I was to double click on the LAN interface, and again, we're looking at this in the outbound direction toward the LAN, notice how FTP is still the top talker. We don't see any drops in the QoS policy stats that have now appeared. Like if I was to right click on my voice class, I see no drops. That's good. Same with my video class. No drops. That's good. If I come and look at my real-time MediaNet information, no packet loss being reported there, so I know my calls are performing well from an application standpoint, so I know that I've fixed that problem and I've protected my tunnel traffic from my internet traffic. So I'm going to switch back to our slides, and we've just done our demo, and that really brings us to the end of our conversation today. So here are several resources that you'll have available to you, and don't worry about writing these down. This slide presentation as well as a video of this presentation will be available on our website very soon. And I'd definitely like to thank you for joining us today. One thing I want to note is if you like what you've seen of LiveAction today, and this seems like a type of application and management tool that you might like to investigate further in your own network environment, feel free to log into our website and download a free trial copy of that. And then also feel free to reach out to me personally and to ask any questions as you go through that trial. I'm a technical resource that can help you with anything from the installation and configuration of LiveAction and getting the best use out of that tool in your environment, as well as helping you see how LiveAction can help you with QoS configurations, validating QoS, and as well how to deploy QoS for your DMVPN networks. Thank you guys so much for attending. Have a good day.